This is Foundations of Math in Pre-Calculus 10, Chapter 3.2. We're going to be looking at the sine and cosine ratios. So using the legs of a triangle is great for solving some problems, but it would be convenient to solve problems involving the hypotenuse. So we have sine and cosine here to help us. Just a reminder, we have a triangle, we have an angle on that triangle other than the right angle. So the side touching this angle is called the adjacent side. The side not touching is called opposite. And the side opposite the 90 degrees is called the hypotenuse. And remember, we learned a mnemonic, SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now, we need to be able to label the triangles in a consistent manner so that we know what we're looking for. The side opposite the capital letter is written in lowercase. So angle A, the opposite side is little a, and we say BC. We can write two vertices, and that means a side. And if we just draw a line over it, this means length. So if we want just the side, we write that. So little b opposite capital B, this is equivalent to AC, and side C is equivalent to AB. So again, uppercase we use for angles, lowercase is opposite the same uppercase letter for the side. Okay, so for sine, we have three basic problems. Solve for the angle, solve for opposite, solve for hypotenuse. And when do we use this? Well, when we have opposite and hypotenuse. Remember, we had opposite and adjacent. That means we use tangent. And let's look at some problems. Okay, solve for the angle. So we must be given opposite and hypotenuse. So sine theta equals 3 over 6. Theta equals, remember, this is not to the power of -1. This is inverse. And we have, it's not approximate, this is actually exact, it's 30 degrees. Now, if we have to solve for the opposite side, and we're given the angle and the hypotenuse, you say sine 30 equals x over 6, and x being the opposite. So x equals 6 sine 30, and this equals 3. Finally, we need to solve for the hypotenuse when we're given theta and the opposite side. So sine 30 equals 3 over x, and x with some cross multiplication is 3 sine 30, and x equals 6 over. Okay, so again, if you're having trouble with the algebra, we simply have theta equals inverse sine of opposite over hypotenuse. And the opposite equals the hypotenuse sine theta. And hypotenuse equals opposite divided by sine theta. Now let's look at the three basic problems for cosine. Again, if we're given just the hypotenuse and adjacent, or we're solving for hypotenuse or adjacent and we're given the other one, then we use cosine. If we're solving for hypotenuse or opposite and we have one or the other, we're solving using sine. So always look at what you have and want to figure out which trig ratio you need to use. Okay, solving for theta. This is almost identical to sine, so cos theta equals 5 over 6. It's adjacent over hypotenuse. Theta equals inverse cos 5 over 6. And this gives us approximately 33.56 degrees. So whenever we're solving for the angle, we have to put in the degrees. If we're solving for our length, we don't put the degrees. If there's units, we put units. Solve for the adjacent given theta and hypotenuse. So cosine 34 equals x over 6. X equals 6 cos 34 degrees. So x is approximately equal to 4.97. And solve for the hypotenuse, given theta and the adjacent. Cos 34 equals 5 over x. Cross multiply, x equals 5 over cos 34. So that is approximately 6.03. Okay, let's verify these on our calculator. Okay, we're going to start off with inverse cos, 5 divided by 6. And we get 33.56 degrees. It's rounded off. And again, inverse cos, 5 divided by 6. And we get the same answer. Next one, x equals 6 times cos 34. 6 times cos 34. 6 times cos 34. And we get 4.97. Finally, x equals 5 divided by cos 34. 5 divided by cos 34. And we got 6.03 for both of them. You try the sine example and make sure you get the same values. Okay, so note that to see the solutions, you must recognize what problem you have so that you use the correct solution or trig function. Draw a diagram, and that's the best way to see this. Okay, on my farm, I want to set up a wind turbine, and to get the most power, it must be mounted at least 60 feet tall. Because the buildings and the trees are about 30 feet tall, it needs to be 30 feet higher than that to get the best wind. Now, guy wires must be attached to anchors on the ground 30 feet from the tower. The wires must be attached at 40 degrees, 51 degrees, and 59 degrees. How long is each wire? So let's draw a general diagram. This is our angle. The base is 30 feet. And what we want to find out is the length of the wire. This is adjacent and hypotenuse. That's ka. So cosine theta equals 30 over x. So we do our algebra. 30 over cos theta. Now we can just plug in the three values to get our answers. So x1 equals 30 over cos 40, and that gives us approximately 39.1 feet. x2 equals 30 over cos 51, and that gives us approximately 47.7 feet. x3 equals 30 over cos 59, and that is approximately 58.2 feet. Okay, that's quick and easy. On Grouse Mountain, the top of the cut is at 1,100 meters altitude. Always pick off the important values. The bottom is at 900 meters. The average angular run is 11.3 meters. How long is the run? Let's just draw this out. We have 11.3 degrees. We have 1,100 meters. We have 900 meters. So this distance is actually 200 meters. Okay, 1,100 minus 900. We want to figure out the length of the run. So we have hypotenuse and opposite. So we're using sine. So opposite over hypotenuse. Sine 11.3 degrees equals 200 over x. So x equals 200 over sine 11.3 degrees. And that gives us approximately 1020 meters. Final example. Jen and Arnold are standing at different spots looking up at the top of a Douglas fir in Cathedral Grove on Vancouver Island. Okay, they're looking at the top of a cedar. Jen has an angle of elevation of 58 degrees to one of the tallest trees there. Arnold has 72 degrees. Jen has a laser distance measure and finds that she is 88.2 meters from the top of the tree. Okay, so that's important, that's important, that's important. Assume both are measuring from a height of 1.5 meters. So that's where their eye level is. How tall is the tree and how far are each of them from the tree? Draw a diagram. We'll be like Bob Ross here and draw some trees. Okay, Jan has a slightly lower angle. And Arnold has a steeper angle. Not to scale. This is 72 degrees. This is 58 degrees. Make sure you put the right person with the right angle. And this is 1.5 meters. This is 88.2 meters. We're looking for this distance. We'll call it D1. And we're looking for this distance. And we'll call it D2. We're going to figure out H here. And we're also going to figure out the height of the tree. Call that T. Okay, we have everything we need. So let's calculate H first because we have this and this. We have nothing here. We have no sides here, so we can't do any calculations with Arnold. We have to do our calculations with Jen first. We want this side, so that's opposite of 58 degrees. We have opposite and hypotenuse. So we're doing sine. Sine 58 equals H over 88.2. H equals 88.2 sine 58. And that's approximately 74.8. We can do this on the calculator. 88.2 times sine 58. 74.8 meters. So label the diagram 74.8. We can now figure out the height of the tree. T equals 74.8 plus 1.5 meters. So this is roughly 76.3 meters. Let's highlight our answers. Next, we need to figure out how far away Jen is. So we can use cosine. Okay, we want to figure out D1. We know this. It's always better to use an original value rather than a calculated value because you might get rounding errors. Cos 58 equals D1 divided by 88.2. So D1 equals 88.2 times cos 58. And that is approximately 46.7. Now, the only one left to calculate is D2. So tan 72 degrees equals 74.8 divided by D2. D2 equals 74.8 divided by tan 72. And that gives us approximately 24.3. And because Arnold has a higher angle than Jen, we would expect him to be closer. And we just have to answer the question. And it's best to round this off to just meters because the measuring devices aren't accurate enough to give us decimal values. So tree is 76 meters tall. And part of the reason is they're not necessarily at the same elevation as the tree. Jen is 47 meters from tree. Arnold is 24 meters from tree. And that completes this lesson.